All right, welcome back. So today, in this lecture, we're going to learn a little bit about modules and packages. So we've been using these for um, almost all the lectures since the beginning, but we figured we would uh, explain the mystery to you of what is happening. So modules and packaging are just a way that you can import code that is already written either by yourself or by somebody else. So one of the really good things that people like about Python is that it's an open source language, which means that the full source code of the whole language is available. And it's also a very large community of open source developers who take it upon themselves to enhance the base language with specialized functionality that's useful for a variety of different things. So the one that we have been looking at this whole time is ArcPy package, which is where Esri took all of the functionality that's inside of ArcMap and built it into Python. So that way any Python developer who has a license for Esri can do all of the Esri stuff that you can do inside of ArcMap, but you can do it from Python instead of having to open up ArcMap. So that is not an example of free and open source software, the Esri package. So free and open source software is often called FOSS, F-O-S-S, because it is not free. You have to pay a license for Esri in order to be able to use it. So even though Python is an open source language, the Esri ArcPy solution for doing GIS is not free or open source. But there are plenty of free and open source Python packages out there. So two very commonly used ones that we'll look at later in the course are SciPy and NumPy. But basically, if you need to do something with code, there's a pretty good chance that somebody has already written it in the Python language. So when you're building your solution, you just need to find the right packages and modules and figure out how to use them. So you have to do the software engineering to link a bunch of components together to solve the particular problem that you were attempting to solve. So modules and packaging are, very, very important because you're going to spend a lot of your time looking around for existing code that already does what you're trying to do by just typing the words into Google. So if you wanted to do natural language processing, you're going to type in Python natural language processing, and it's going to bring you to some online courses, and then eventually it's going to bring you to the NLTK toolkit, natural language processing toolkit for Python, right? So in a gigantic natural language processing package that basically does everything you would ever need to do in natural language processing. If you wanted to develop your own natural language processing algorithm, you could leverage what is already inside of here and build just the new science pieces that you wanted to. You want to do Python GIS without Esri. It's going to be on this list somewhere. Best tutorial. Grass is an option for you. So Grass is another GIS package that you could use instead of Esri. I'm not super familiar with it, but I know that a lot of people use it. So you could do most of the GIS stuff you needed to do for free without Esri. Another one is Surge Rays. I never remember the name of it. PySal. Oh, if it comes up, yeah, it does. So PySal is Python Spatial Analysis Library. So this is developed by Serge Ray out of Arizona State, or University of Arizona. I should probably know that. PyCell, Arizona State. So there's a faculty member at Arizona State named Serge Ray, and he spends a lot of his time developing Python for doing GIS processing outside of ArcGIS. So they have a set of specialized functions that they've done, which are not included in ArcGIS, and then they also have just some basic stuff like vector handling, raster handling, all that kind of stuff. So long and the short is, anything that you think you need to do in Python, there's a really good chance somebody else has already written it. And all you have to do is find it, bring it in, test it, make sure it solves your problem, and then move on with your life. The best line of code is one you don't have to write, that somebody has already written, that somebody else is already supporting, that you can just utilize without having to go through all of the engineering to build it yourself. So we're going to look at the difference between modules and packages, as well as import versus the multiple ways you can import. So this is pretty simple. You're going to hear the words module, package, library, sometimes plugin when people are talking about, oh, did you get that sweet new Python plugin or that sweet new Python library? The only two really official words are modules and packages. Library and plugin are used generally by people who are coming from other languages where those words are used more commonly. All right, so let's jump into it. So a module is just a Python file, a .py file that contains anything. Right, so you have been making .py files for your homeworks. If you've been following along with the lectures, making those files, you've named each one of them something .py. Congratulations, you have now made Python modules. You can make files that don't have, like Python files that don't have a lot of useful functionality in them. They might just be little scripts that run other scripts that run other scripts. But they are still Python modules. So anything named filename.py is the file name module. And you can then import stuff from that module or from that Python file. The reason that we might want to separate our code into different .py files, into different modules, is to keep it organized. So you only want to write code once and reuse it in multiple places. So you're going to run into a situation where you need to write some kind of helper function. So once you write that helper function, you could keep it just in your gigantic file where you needed it, or you could move it into its own separate file as its own separate module. Keeping it in your gigantic file makes it harder to share between the next time you need to use that same helper function again. So generally what you'll do is you'll start building up like the stringutils.py file, which inside of that is going to have all your weird string helper functions that you've ever needed, like parse phone number, or parse zip code, or parse well number, or any kind of weird thing that you have to do more than once to a string to make it usable for you. So what most programmers do is they take all of those string functions, put them into the string helpers.py, take all of your helper functions for numbers, put them into number functions, number helpers.py, take all of your raster helpers and put them into raster helpers.py. So that way you can reuse your code easily. That also helps with testing. So you can develop unit tests that you wrap around each of those functions. A unit test is where you give a known input to a function and then verify that the output works properly. So you can automate the testing of all of your code to make sure that things work every time you make a change in anything. So modules make your code more modular, in that you can take little chunks and bring them into the place you need them when you need them, but keep them in their own home. So that way you can maintain them separately, or when you make changes elsewhere, you don't need to worry about changes that happen inside of there. So every single file you've ever made has been called .py, and each one of those has been itself a module. So packages are just collections of modules where they share the same name using the path attribute across the top. Because you can imagine that ArcPy, the whole gigantic package of everything that Esri offers, is not just in one file, right? It's probably put into a bunch of separate files, one for each of the tools. So one for buffering, one for clipping, one for doing zonal statistics, one for doing export to CSV. They're probably organized multiple per file, multiple per module, which are related to each other. So the spatial analyst toolbox might be itself a module, or it might have some submodules inside of it. But all of that gigantic Esri capability that you get, you reference it all just by arcpy dot something, right? So to convert your modules, so your multiple separate .py files into your own package, you just have to share the same path name or path attribute inside of them. So there'll be an example for that added in here. So when we've been using ArcPy, that is a package because it's a group of modules that are all together that you can reference via the same name. NumPy is a package. It's a group of modules that are all together that you can reference with the same name. Same with SciPy. So there is no mystery here, right? So modules and packages are both just .py files that you have created some useful code in. And a package is just where you put the path attribute inside of them. So Python knows that they're all supposed to be together. So a library is not an official Python anything, but you will hear it used instead of the word, which is official, package. Same thing with plugin. There's no library, there's no Python libraries, there's no Python plugins. There are Python modules and packages, but people use words incorrectly all the time, and this is one of them. All right, so now let's look at some import statements. So we have been using the word import ArcPy at the top of every single file that we have been working on, almost exhaustively this semester. This is how you import a package or a module into your code, so that way you can use all the things that are contained inside of it. So that way you don't have to rewrite all of that stuff. So there's a lot of different versions or flavors of import statements. We have been using the generic vanilla one, just import ArcPy, end of line. You will see from time to time a variety of other ones. This first one we're looking at here, import NumPy as NP, does all of the work of importing the NumPy package, and then just renames the variable NumPy to NP. So this way, when you want to run a NumPy dot something, you just write NP dot something. So as keyword is common in a lot of languages, and all it does is give you another name that you can refer to something by. So if you thought NumPy, 5 letters, was too many, congratulations, there is a way that you can now make that smaller, and you can just do NP 2 letters instead of NumPy. There might be reasons why you want to do this for keeping your code organized. So if you're importing a series of things and it's easier for you or easier for your firm to use consistent naming for things, then this is how you could accomplish that. So you can import name of package as anything you like. So you can rename that package in your code and your references to something else. Not super complicated. All right, next we have from blank, import blank. So this is another flavor of how to do an import statement at the top of your file for including packages and modules from external to your code. This version allows you to specify which things inside of a package or module you want to import. So if you are working with something gigantic like ArcPy, you might not want to import the thousands of available classes that ArcPy has. You might just want to import only the thing that you need. The reason you might want to do this is it saves memory because Python doesn't have to load a bunch of things that it's not using. And it could potentially make your code run faster because the Python engine, even though it is very, very, very optimized for finding things, will have less things to look through as it's trying to find the exact piece of code that you're looking to run. So you can do the second statement where it says from NumPy import a very specific thing. So it's only going to load the ND array from NumPy. Or you can do from NumPy import star, which is import everything, which is the same as just a regular import statement. This statement from NumPy import star and import NumPy as NP or with or without that are equivalent. Import NumPy and from NumPy import star both import the entirety of the NumPy package. So how do you know which one to use? Whichever one your company uses, that's the one to use. You can change it back and forth. So if you go to find any piece of code online and it uses one or the other, you can switch them back and forth and it will make no difference. You can import a specific thing just as you need it, or you can import everything. You know, for most purposes, it's not going to make a difference either. So as you are tuning your code and about to go into production and release a version of your code, you might start going through and importing specific things rather than importing an entirety of a package. Or you can just be a better programmer and just import the things you want only as you are writing your code the first time. So no big mystery here either. Basically, you're going to see both as you're looking around on Stack Overflow. Just wanted to make sure you know that they are mostly equivalent and you can use them interchangeably. All right, so how do we create a module and use a module? You have already done this. So creating a module just means putting it in a .py file, right? So if we have an addition function, which we think is super awesome, and we're going to need it all around our code, so we better keep it as its own special thing, just put it into the math.py package or the addition.py package by creating a file called math.py or addition.py and putting your code in there. And then when you want to use it inside of another file called test.py, you just do your import statement, and as long as it's available, the addition.py file, Python will import it. So how do you know if it's available? If it's in the same directory, it's automatically available. Otherwise, you can put it in the Python packages folder, which is where Python looks for everything that it should know about as a package. So that's about it. Now addition.py is available inside of test.py, right? So mystery solved. What are packages and how do they work and how do you make them? You've been making them the whole time. So I guess the key things here are that modules and packages allow you to import code from other people or from yourself. You would like to import it from other people because other people have probably already done the thing that you would like done, and you would like to use code that is already written rather than have to reinvent the wheel yourself. If you are inventing new things, you would like to keep it organized so that way your code is reusable across multiple components that you're going to be writing through the history of your programming career. This allows you to write once and reuse often. It also allows you to do more formalized testing of your code by having separate packages that handle specific functions where those functions can be tested rigorously. Import statements, you can use import or you can use from blank, import blank. They do the exact same thing. The as keyword just allows you to rename a long name into a short name, and the from blank import something allows you to import everything with a star or just a specific component by using its name. So kind of short lecture, but hopefully it solves a lot of the mysteries that you were wondering about how all this stuff works. So there you go.